Problem 6, we have this question. We know the setup. Bucky rode his bike at 12 miles per hour, and after some point, he walked his bike at 4 miles per hour. The entire trip of 22 miles took 2 hours. And the question is, how far did he travel on his bike? All right, so we know just by the virtue of miles per hour that a rate equals the distance divided by the time. Now we could rewrite this as distance equals rate times time. And that's what I do here. I create a table where I set up distance equals rate times time, and then I want to figure out some different pieces of that, what that was when I was biking, walking, and then in total. So I start to put in some information. I know that my total distance was 22 miles. I know that my total time was 2 hours. I know that my biking rate was 12 miles per hour, and that my walking rate was 4 miles per hour. Now the parts that I don't know, and I'm going to leave out this total rate, it functions a bit differently. Of course we could see that it's, if we went a total distance of 22 miles in 2 hours, that our average rate was 11 miles per hour, but we don't necessarily need that. So I'm just going to leave that blank in this part. But I am defining some variables. D sub b is the distance in miles of bike riding. A lot of students on this exam said like x is the distance, but then you treated it as a time. So you need to keep in mind what you're doing and try to be organized and not shortcut. So in this case, I'm making my variables very clear and very obvious. So d sub b is the distance of biking in miles, and d sub w is the distance in miles of walking. And likewise, t sub b is the time in hours of biking, and t sub w is the time in hours of walking. So I know a few things. I know that the distance I biked plus the distance I walked gives me 22. And I also know that the time I biked plus the time I walked equals 2 hours. So I can use that information to adjust my chart. What I want to do is try to get down to where I have fewer and fewer variables, because if I can do that, then I have a chance of figuring out what that unknown quantity is. In my case, I want to know how far, so I want to know the distance traveled on the bike. Some people stopped at answering the time on the bike, and that's not quite what the question's asking. So now, given that d sub b plus d sub w equals 22, I could rewrite that and say, well, d sub w must equal 22 minus d sub b if I subtracted d sub b on both sides. So instead of writing d sub w here, I can write 22 minus d sub b. Some students flip these around, and I think that's a shortcutting mistake by not thinking through this equation clearly enough. Most of you wouldn't. If you were solving for d sub w, you would know that you're subtracting the d sub b, so you would have a minus d sub b. Okay, and then I'm going to do an analogous thing over here. I don't necessarily have to, but I'm good. Now you can come to the solution for this problem in a couple different ways. I'm going to solve directly for d sub b, but you could solve for t sub b and then work it backwards through your equations to figure out what d sub b is. Okay, so I use the fact that my pieces equal my total here, but I also know that my distance equals my rate times time. So I can create a relationship here that says d sub b equals 12 times t sub b. And also 22 minus d sub b equals 4 times the 2 minus t sub b. So I can create that relationship too. Now when I do that, I can make some different relationships. So for example here, I can say if I'm solving for t sub b, I can divide both sides by 12. When I divide by 12 here, I get t sub b, and here I get d sub b over 12. So I can rewrite my time in terms of distance and rate. So I know that d sub b equals 12 times d sub b divided by 12. That's very straightforward. So I can rewrite my time in terms of my distance and my rate. And that's what I did here. I took the distance and divided it by the rate, and that gave me my time in those terms. Then using that fact, again I can say my time biking plus my time walking has to give me my total time. And that's what I said here. My time biking plus my time walking must give me my total time. Now I have an equation that only has one variable, so I can solve for that. So I multiplied by 12 on both sides, keeping track of distributing. So since this is divided by 12 already, multiplying by 12 gives me my whole d sub b. This is divided by 4, so that means multiplying by 12 gives me 3 sets of this. And then, of course, multiplying 2 by 12 gives me 24. I'm going to distribute my 3, so now I'm to this row. And when I combine my like terms and subtract 66 on both sides, I get negative 2 d sub b. Remember, d sub b is the distance biking. That equals negative 42. And so when I divide by negative 2, I find that my distance biking is equal to 21 miles. Now I could use this process to figure out what my distance walking was. Of course, that'd be 22 minus 21, so 1 mile walking. And of course, I could also plug those in to figure out how much time that was. So 21 twelfths would be my time biking, and then 1/4 would be my time walking. Okay. So having an organized system that can help me connect my different equations, I started with 4 things that I didn't know, 4 variables, but using these connections, creating equations, allowed me to replace some of the things I didn't know and make relationships. Once I did that, I could get down to a situation where I only had one variable, and I chose to keep the variable that was the question I wanted answered first. Then I could create an equation based off of that to solve for that variable that I didn't know.